Today, I'd like to talk about interpreting the derivative. So as a reminder, the definition of derivative involves a limit of a difference quotient. This is just a difference quotient because we're subtracting and then dividing. The difference quotient itself gives us an expression for the average rate of change. And we can think about that as a change in output over change in input. So the f of x plus h minus f of x would be our delta y, and the h is the delta x. So this should look very familiar to us from slope formulas. So it's a good way to remind us to think about interpreting a derivative as a slope. And we can think about the units specifically from this slope interpretation. So the units on a derivative should be the change in output over the change in input. And sometimes that can be very helpful when we're interpreting a problem. Notation-wise, f prime of x is one way we can denote the derivative. And another notation is to call this df dx. And I hope you can notice that the df dx is somewhat similar to the delta y delta x, or delta f delta x. So delta y delta x would be the average rate of change. And if we think of this as df dx, that would be the instantaneous rate of change. So the first two pieces of notation here, f prime of x and df dx, I interpret as the derivative of f with respect to x. And this with respect to is so common, mathematicians will sometimes abbreviate that as WRT. This phrase here, you could just memorize this phrase, the derivative of f with respect to x. It's a great way to instantly translate from the math to English. The last piece of notation here, you'll notice I've kind of split the d and the dx away from the f, kind of separate those up into two pieces. It basically means the same thing. We're still talking about a derivative, but for me, it feels more like a command or an operator. It's more like telling you to do something. So I interpret this as a command. Take the derivative or find the derivative. So to me, it's more like telling me to do something. It's like, oh, here's my function f. I need to take the derivative of it, or I at least need to be thinking about the derivative of that. Okay, let's say that f of x is measuring distance. And then we could think about x measuring time. What are the units on the derivative? That's the question we want to tackle. So let's throw some units on here. I told you that f is measuring distance. Let's use meters. And x measures time, so let's do seconds. So the units on f, if we go ahead and think about this change in output over change in input perspective, or even coming straight to the definition here, f is being measured in meters. So if we take meters and subtract meters, the entire numerator is being measured in meters. And h is being measured in, well, h is the input, so h will be measured in seconds. And so the units on f of x would be meters per second, meters divided by second. So hopefully you can see where that's coming straight from the definition to help us with this interpretation.